Hello guys, welcome again in this new tutorial. Today we will talk about this ultrasonic sensor, or is the HC-SR04 module. This sensor is an ultrasonic sensor. It's got a transmitter and receiver parts, where the transmitter will be transmitting an ultrasonic waves to estimate or detect the distance of the obstacles. Okay, so for example, I have an obstacle at this position, so the transmitter will be continuously, or not continuously, we'll see how to program it later, the transmitter will be sending waves that will hit the obstacle and bounce back to the receiver. And this sensor is very fast and smart enough to calculate the time between the transmitter that's transmitting the ultrasonic until it gets back the response or the bounce back signal. Then from the time and we know the speed of sound, so we can calculate or estimate the distance. Okay, so this is what we will talk about today, and we will try to hook it to the Arduino, program it, and also we will learn how to calibrate it if needed after we test it on the real world application. Then we see if it's needed to be calibrated or no. Okay guys, so without further ado, let's get started. Okay guys, so here I downloaded the data sheet for our HC-SR04 ultrasonic sensor. Okay, this is the SR04 module, and yeah, this data sheet is from Multicom Pro, because I found different data sheets for these modules, but I guess this is the more informative one. Okay, again, this is how it looks like, but mine is blue, this is red color. And if you see here, we got T and R, or transmitter and receiver. This one, we will talk about it later. So if you see the specs here, the trigger pulse is about 10 microsecond. We will talk about this again later. Output TTL is directly connected to the Arduino, 5 volt tolerance. Power supply, 5 volt DC, good. Quiescent current less than 2 milliamp, good. Working current 15 milliamp, acceptable. Detection degree is the degree that's able to be detected is about 15 degrees, should be fine. And the range is 2 to 450 cm, which is quite good. So now let's talk about how it works. Let me open the paint, or not NewPing. Let me open this. Okay, I'll take a screenshot of this guy. Okay, so how it works. So for example, I have this sensor here. Let me draw a red color. Let me draw an obstacle here. So let's say there's an obstacle here. Okay, this is, let's say, a wall. So how this guy works is the transmitter will be transmitted a wave of ultrasonic pulses. Then since it will hit the obstacle or hit the wall, then it will bounce back. It will bounce back all the way to the receiver. Okay, so it will go from the transmitter this way, bounce back at the solid object or obstacle, then it will bounce back to the receiver. Then the system inside will be timing the time where it's send the pulse at the transmitter until it's received the pulse at the receiver. Okay, or let's draw it like this. So this is a transmitter. Now I'll draw the receiver down. Let's say it will receive it somewhere here. So the distance between this and this, okay. So this we can time this difference between these two pulses. and compared to the speed of sound, so we can calculate the distance or estimate the distance between the sensor and the object. Okay, we can estimate the distance. Okay, so this is how it works. Yeah, using this concept. And how to program it here, they give us the working principles. So first, we need to send this. Let me take new screenshots. Yeah. Okay, so the working principle again, we need to send a trigger of about 10 microsecond. Okay, first we trigger it with 10 microsecond. Then the ultrasonic internally will produce 8 cycles of sonic burst. Okay, it will burst 8 times. This means the transmitter. Do you remember we have transmitter, then we have a receiver. This all was on our sensor just now, the one we explained. So this transmitter will be sending 8 bursts to whatever there. Let's say if there is, let's say there's an obstacle here. Okay, this is an obstacle. So the transmitter will be sending this 8 bursts to search for any obstacle. Then this will be, let's say, bounce back here. Then it will go back to the receiver. Then when we receive the signal here, so there will be have an echo that we receive it, so we can calculate the time between the cycles of, sorry, I mean the sonics that the module being transmitted until we receive the signal. So this is the time that I told you we need to calculate, and this is where we'll see how they calculate it later in the code. Okay, so this is how it works. What else? And again, the 8 cycles will be at 40 kilohertz. And what else? So yeah, this is how we can calculate the ultrasonic wave. This is speed multiplied by time divided by 2. And why we divide by 2, by the way, because we have 2 times the time where the 8 sonic bursts being transmitted to the object. So this is time 1, and another time will be bounced back and go back to the receiver. So this is time 2. Okay, so that's why our final time, let's say this is time, so this one we need to divide by 2. That's why they mention here divide by 2, because we have the sending and receiving. Okay, so we have to have the half distance. We don't want to have the full, I mean, how can I say, the sending and receiving distance. Okay, so here is the wiring diagram. We have ground and VCC. VCC again is a 5-volt tolerance. And then we have a trigger control signal. This is the one that we need to hold it up for about 10 microseconds. Then we need to monitor the echo in case we receive any echo signals, so we can time the time between these the trigger and the echo. Okay, so that's it, guys. So now we will go to hook our sensor to the Arduino and start our coding. Yeah, so here I connect the ultrasonic sensor to the Arduino. So here I use extension. Okay, so if you notice here, I connect the ground to the ground, VCC to VCC, and the trigger pin I connected to pin number 9 of the Arduino, and the echo connected to pin number 10. Okay, that's easy. We need only 4 wires. Again, VCC to 5 volts in the Arduino, ground to the ground. Trigger of the HC or the ultrasonic sensor will be connected to pin number 9 of the Arduino, and the echo pin will connect it to pin number 10 of the Arduino. Now let's go and do the coding. Well, so we will start with the coding. So here I open a new fresh sketch for Arduino. Okay, so let's get started. So before that, let me remind you guys about the hardware connection. Okay, so this is the connections. So again, we have VCC. We go to VCC. So let's say this is the HC sensor. Then here is the Uno or the Arduino, whatever MCU. So VCC, then we have GND, for sure go to GND. What else? We have the trigger, go to pin number 9. Then we have echo, goes to pin number 10. Yep. Okay. And yeah, it's good to highlight it here, guys. Actually 9 and 10 is just that I'm using these pins. You can use any other pins. There is no restrict on that. Okay, so yeah, this is what it is. So now we need to define, let's say hash define let's say trigger pin will be again number 9, and hash define echo pin, which is number 10. That's good. Then we need to declare 2 variables that, sorry, we keep it later on the way where we want to use them. So here to put the code that we run once, which is declaration. So we need to have the bin mode. Yep, pin mode. The pin number is the trigger pin. So trigger definitely will be output. Okay, because we are sending data out, or we send data to the sensor. Then we have pin mode again for the echo. Yep. Echo pin, echo will be input. Yep. Let's see if everything is good. Oh yeah, this one shouldn't be equal, sorry. So there's no equal in the define. Okay, good. Now compiler is happy. So now we need to declare our serial. So our serial, will declare it in baud rate of 9600. Okay. So now in the loop, as we discussed, or as I showed you previously, we need to set the trigger pin to high. So I need to digital write. I need to digital write the trigger pin to high. For how long? Delay microseconds. Yes, I need to delay it or hold it high for 10 microseconds. Then bring it low. So let's just copy this, copy and paste. So this one will be low. Yeah, so we already hold it for 10 seconds, then the rest will be low. So this is just to trigger it. So now the sensor will be sending the what they call the 8 bursts of or 8 sonics of the waveform to measure the distance, start to sending these forms. Okay, so now I will measure the echo or time the echo. So I need the duration. So now the duration, and since duration it's expected to be in, how can I say, in floats, or what they call decimal, got some decimal points, so I will declare it as float. So float duration. Okay. So duration will be equal to pulse. So now I want to measure the pulse. So pulse in, yes. Echo pin, I want to measure the echo pin, and time the high. Here will be high. Okay. What else? So after I got the duration, so now I need to calculate the distance. The distance, again, distance might be might get some decimal points, so I will need the edit here, distance. Okay, so the distance, we need to have the duration. Okay, we multiply by the speed of sound, and then we need to divide by 2. Why? We will explain now. So what we have, the speed of sound is equal to 340 meter per second. But here we are dealing, if you see here, all we deal in micros. Okay, this one also return a micros. So to convert the speed of sound from meter per second, we need to convert it to centimeter per microsecond. So it will be equal to 0.034. This one will be cm per microsecond. Okay, so this is the conversion. So this is the speed of time. So distance will be equal to the duration multiplied by the speed of time. What speed of sound? So speed of sound will be 0.034. Let's put this in brackets. Yep. Okay. Now we divide by 2. Why we divide by 2? Because, let's put this, because if you remember, guys, we have 2 times the, how can I say, so the total time, okay, the total time that we get from here, total duration, will be equal to the transmission, or what we call TX time, plus receiving time, RX time. Okay, because this one will be sending the waves into the what we call the objects, and then the object will bounce back to the receive time. So we have 2 times the transmitter time and receiving time. So that's why we have 2 times, so we need to divide by 2 to get only one, the distance between the source of the sensor until the object. So yeah, so that's why we need to divide by 2. Okay, I believe that's it. So now we just need to print our readings. So we have our serial dot print. Here, let's see what we want to print. So we have the distance equal to this. Then we have serial dot print. We print the distance itself. Okay, then we print the unit, which is the serial dot print, and here line, we add the line, so it will be moved to the next line at the end of this. So here we'll be printing the units, which is centimeter. Then let's add a delay for our readings to make it kind of stable. So delay, let's say 150. Okay. Okay, I believe that's it, guys. Here's the connections, then the pinouts, then we need these what they call variables that we're working on, their flows, duration, and the distance. Then we declare the trigger output to go into the sensor. Then we read the input from the echo pin. Then again, as we saw in the data sheet, we need to set the trigger pin to high. Okay, for 10 microseconds, they bring it low. Then we time the echo pin. Yep. So we find the pulse, and this pulse is a function to return back the duration of the pulse that feedback to the pin, which is the echo pin, which we're starting the duration. Then from duration we multiply by the speed of light or speed of sound. Then we divide by 2 to get the distance between the source or the sensor until the object. Then we display. Let's see which Arduino I'm connecting. Yes, this Arduino. Let's upload it and we test it on the bench. We got here serial was not declared. Okay, so this one I believe it should be capital. Sorry, and this all should be capital. Yep, I believe now should be happy. Yep, it's uploading. Now let's go to the bench. Okay guys, so here is the setup I have done for the testing. Okay, I have added this ultrasonic sensor on this box, and I added this measuring tape so I can see the distance between the sensor and the object. I use this heatsink as a object or the obstacle that will bounce back the signal. Okay, so if you see here, let me focus. So if you see here, the edge of the sensor starts at the 30 cm or 1 foot. So from 30 cm will be my 0. So if I put it, let's say here exactly, so it will be 7 cm. Okay, start from 30 to here, 7 cm. Okay, so now I will overlay the reading from the what do we call the UIArt. Okay, I mean the reading from the Arduino, so we can see the reading while we are changing the distance of the object. Let me increase this. So here, as you can see, guys, let me adjust it. Let's put it at the 5 cm. Okay, make it parallel as much as possible. So if you see now, guys, I have put it at the 5 cm, and you see the reading is about 5.5 cm. Okay, the reading at the serial monitor. Okay, if I change, let's say, to 10, which is 40, okay, the reading is 11 point something, 11.8, 11.7. So if I move again, let's say on 14 cm now, the reading is 13.7, and so on. So now if I change, let's say, to 50, which is 50 minus 30, so what, 20 cm now, 20 cm, 20.8. So we can notice that the reading not that very accurate, which we can later improve it by using the calibration method. Okay, so we can go now all the way to 60. Oops, it's out of the camera, but believe me, I put it on 60 but show 30 wrong. Okay, so now I will change, for example, to 15. Now I should see 15, which is shows like 13.7. Okay, anyway, so it's working now. Okay, now I go back to 6 cm. So yeah, it's working for the time being. However, it's not that accurate. We can improve it later with the calibration. Well, so now we already tested the normal code or the manual code that we drive before. So now we can try the library. I believe there's a library. Let's go to here and we search for NewPing, I guess. Yes, NewPing allows ultrasonic sensor. Yes, so we will install this NewPing to directly trigger and deal with our sensor. Okay, so I will install. Okay, it's downloading, installing, and it's success. Good. Okay, so now we can go to the examples. Let's see, where's our NewPing? NewPing. Okay, NewPing sensor timer. Okay. What is this? This is the first time, guys, I'm exploring this library with you. Okay, so this one, I guess, from here, it looks like it will communicate and trigger about 15 ultrasonic sensors, and it will do some funny things. Okay, that's cool. Let's see the rest, what we can have also. NewPing. So we have three sensors. Yeah, you can see a NewPing 15 sensors timer. Then we have three sensors. Then NewPing event timer. We don't want ping example, NewPing example timer module timer example. We don't want. We just want the normal one, I can say, without any timer. Let's see what we get in this. Okay, so this example, NewPing that does a ping of about 20 times per second. This mean it will acquire the distance or ping the distance for 20 times per second. That's good. I mean we have some delay up here, so it's mean 15 per second ping is mean 20 times per second, whatever. So here we have the trigger pin 12, echo pin 11, and the maximum distance is 200, mean 20 cm. Okay, then we have the sonar, our trigger pin, echo, and the maximum distance. So this is the object that we are initiate to be used, and this is the serial, and here is the readings. So I believe the readings will come here, ping in cm. Okay, that's good. But if you remember, guys, if I'm not mistaken, my trigger is 9. Echo pin 10. I don't want to change the hardware setup for time pin. I'll just keep it as it is. And here, let's increase it. I don't want only 20 cm, I want 30. Okay, let's compile. Okay, the rest should be good. Yeah, the Calibration compiler should be happy we didn't change much. So yeah, so now I will download this into our Arduino Uno and we see the result. Okay, good. So now guys, you can see again, this is our setup. So here is our sensor and this is our object or the obstacle or the reflector that will bounce back the signal, go back. Or this is the object that we will use it as an obstacle that the ultrasonic beam will be bounced back at this object and return back to the receiver. Okay, and here is our measuring tape to verify our distance. Okay, again we start at the 30. Here is the 30 cm, so 30 to 40 is about again 10 cms. So now I'll overlay the reading from the UART, Arduino UART, which is this time from the what we call is from the new library, which is called the NewPing. Okay, So again, as you can see here, guys, is kind of accurate, more accurate than the one we did it manually. So you can see here is a 10 cm, exactly what we are setting here. So if I move it to 9, so now I should see 9 cm, still 10. I need to move it maybe until 7, I can see 8. Again, it's not that accurate, yet I can see it's kind of stable, it's not flickering as maybe the previous one. So I can go down to, let's say, 5. 5 will give me 5, okay, good. I go back again to 10. Give me 11, just now was 10. I guess if I move it a bit, no, yeah, you see, if I move it a bit, it will become 10. I bring it back, become 11. Anyway, we will try to solve this issue using the calibration. So now if I go further, let's say 16, because here we have 10 plus 6, 16. So you see, we have the readings is 17. I go to 50, which is 20 should be here. Yep, it is 20. If I go to 25, yes, 25 looks nice. 15, yep. And here should be 10. Okay, guys, so with this is our reading from the library this time. So now we can go and try to write some code to calibrate our readings. Okay, guys, so here is the calibration code for the HC-SR04 Ultrasonic Sensor. So I used the NewPing library example, okay, as you can see here, and I add on the calibration code. From here, the trigger and the echo pin being adjusted accordingly to pin number 9 and 10. Maximum distance changed to 300 millimeter, okay, which is not cm, or 300 mm, which is 30 cm. This is new, okay, I have added this, which is we need these 3 variables to help us in the calibration process, which is the row minimum, row maximum, and the calibration or the calibrated measurement. Here is the what they call the sensor object that we are declaring, which is again is this is from the library example. Here in the setup, I have added these 3 lines, which is I declared the serial monitor with this baud rate, and also it will print some information on the screen for the user, which is it will enter C to run the calibration and R to run the measurements. Okay, so since we are at the first time when we run the system, we need to enter C to calibrate the system. Then we just continue with R or perform the measurements or readings. Okay, so here in the loop, okay, if you see the loop is only here. Okay, this is the only loop function. So in the loop, I will be waiting for the serial to be available. Okay, here waiting for the serial to be available. Then I will read the income character from the serial and I sort in the input. Then if my input is equal to C or R, it will call the related function accordingly, because from here we ask the user to enter either C or R. So if the input character is C, then we will call the calibration function. If R, we'll call the measurement. Okay, so now we need to go and see where is the calibration and measurement function. So the calibration will be here. Okay, so this is the custom function I have built for the calibration. So it will bring the calibration is started, and there's some delay, then it will ask or give some instruction to the user to move the obstacle at certain locations to take the measurements. So first it will ask to move the obstacle to 5 cm, then hit O or send O at the terminal to move to the next or to perform the measurements at that specific location, which is 5 cm. So again, I will go into while loop, which is enter here. Let me close this to have space. Can I have it in one? Yep. Okay, so this is the while loop. exactly. So while 1, which is mean continuously running here and until there's some response from the user, because I ask him to move, and because it might take some time to move the obstacle, then enter O, so we need while loop. So this while loop will continuously running here until it got some response from the user. So if the again serial available and the user send the letter O, the character O from the serial, then it will be read, store here, then it will check if it's equal to O, then it will take the measurement. So from here I have read 32 readings. Okay, I took 32 samples from the sensor, then I average them. Okay, if you see here, I accumulated 32 samples. I have for loop from 0 to 32, accumulate them, then I average them. Then after this is mean up to this line, I have already averaged 32 sample for the minimum row value. Then I just break the loop, break the while loop to exit. Okay, so come here, it will ask you're given the instruction to the user to move the obstacle to 20 cm this time. Okay, this minimum and maximum. So now I'll calculate the maximum, which is again exactly identical to what we did previously. There's a while loop, then it will check if the serial is activated or there's income characters from the user through the serial. Then again read it in through the input, which is if and check it or test it if it's equal to O. Then it will take another 32 measurements, store it in the maximum row, accumulate it here, then after that average them, then it will break the while loop again to move to the next step. Okay, which is next step actually is completed already. I mean, just be like, okay, calibration completed, triggering the measurement, because after we finish the calibration, then I will just call the measurement function. Okay, so the measurement function is just down here. So here's the measurement function, just straightforward, measuring or take the raw readings from the sensor, calibrated or adjusted using the map, Arduino map function, which is exactly following the 2 points calibration. If you go and study the map function, it's just two points calibration function, then that's it. So yeah, again, so from here, if you see the calibrated measurements, it's equal to the map function, which is again takes the parameter we want to calibrate, which is the ping cm function that return, or it will return what they call the value from the ultrasonic, and we will calibrate it from the minimum value to the maximum. Okay, the minimum and maximum we calibrate it to 5 and 20. Okay, do you remember the minimum we calibrated, or we take the average at the 5 cm from the obstacle, now the maximum at about 20. So we set it to 20. Okay, so with that it will perform the calibration for us, or will apply. Okay, will apply, not perform, because all this code will perform the calibration, but only this is to apply our calibration factors. So this one, minimum and maximum, they are the calibration factors that will be mapped from minimum maximum to 5 and 20. Then after that I just print the calibrated measurements to the serial, okay, so the user can read it. And yep, that's it for the calibration part of the sensor. I already compiled it and the compiler is happy. So now I will send it to the Arduino board and we can have a look at the output. Okay guys, so I have already uploaded the new code, the new calibration code to the Arduino. So now I'll open the serial monitor. Okay, so if you have noticed, it will ask us to enter C. Well, I got 2 times, I believe. We can reset it. Yep. So if you enter C for the calibration, R for run, which definitely if we go for run directly, we won't get any good information. So first I will enter C. Enter. There we go. So it will state that calibration is started, move the object to the 5 cm. So now I will move the object to 5 cm, exactly. Okay. So again, it starts from 30 until 35, so this is 5 cm now. Then I will send O, enter. Okay, so it's already performed the measurement for the 5 cm. Now it asks me to go to 20 cm, if you see here. Now I'll move it to 20 cm, is mean 20 cm need to go all the way to 50. So here is the 20 cm. Okay, so this is 20 cm now. I will hit O again, or I will send O. There we go, measurement completed, and you see the measurement exactly 20 cm. Nice, we don't have flicker anymore, we don't have different measurements anymore. So move it now to, let's say, 10 cm. There we go, you see, exactly 10 cm, the measurements won't jump anymore. Now let's move to another place. Okay, which is, you can see here, 7 cm, which is exactly 7 on the measurement. We go, let's say 8, there we go. And here is the 14, yep. Now if I move it, let's say 16. Yeah, so again, this setup is not perfect for these measurements, but again, we managed to get a very good and nice and stable result. Okay guys, so with that, I believe, yep, 6 cm. So with that, I believe we have reached to the end of this tutorial. So before we end up, guys, if you notice that we are not saving the calibration factors, okay, if you come here, let me close my terminal. If you come here, you see the calibration factors, which I mean by the minimum and row, row minimum, row maximum, we are not saving them. So if I reset my terminal again, it will ask to calibrate again, or if we don't want to calibrate, we just want to run, you see it will give us a wrong information because not being calibrated. So to solve this issue, you need to save these factors in the EEPROM of your MCU, which is the Arduino. Otherwise, you need to calibrate it whenever you run the system. So this is a hint or a homework for you guys. You may need to store, after you've done the calibration, you may need to store these two data into your EEPROM. So the next time you're running, you don't need to recalibrate again. I have already explained a lot of examples on the ways to correctly and efficiently store the data in the EEPROM of the Arduino. You may go through that and learn how to do it yourself. Otherwise, you just let me know down below in the comments. I will do for you in the future tutorials. For the time being, I hope you have learned something new from this tutorial, and we have learned how to operate the new HC ultrasonic sensor, how to drive the manual code library, and also how to establish the calibration code as well. So happy learning, and see you soon in the new tutorial.